need Wednesday because there's still going to be some stuff we got to cover. Okay. So 3.6 talks about couples. Couples are kind of a neat thing there. Okay. And what couples do is, let's see, let's get some more paper here. Can I call that paper? Is that legit? So if we look at example 3.11, we've got a situation going on there that looks like this. I'm going to say this, actually they're calling that O, aren't they? OY. Oi. OX. Then we've got A out here. AY. AX equals 0. Then we've got 100 pounds going this way and 100 pounds going this way. And they're saying that the distance here is 4 feet. And you know what the weird thing about this is? That's the only thing I need to know for that moment. They give me that this is 2 feet, I believe. Right? 2 feet, and then there's 3 feet here. If I remember my couples right, I think I do. Yep. If you want to do the moment for this, and I don't think it makes a bit of difference, you can do it based on a couple. It's going to be the force times the distance just right here. You take, it's one force, not both of them, one force times the distance, if you will, between forces. That's it. So the moment here, and you could say, I think you can say at O or oh, you know what? Oh, I'm looking at the wrong one. Between O or A, either one. But the moment at O, if you use the couple, is just 100 pounds times 4 feet. And that's 400, pounds, feet. And that is doing what? Counterclockwise. Now, why would it be counterclockwise? It's really, don't think too hard on this one.
Because the upward force is further away from...
Exactly. Thank you. This force going up, if you will, which makes this go counterclockwise, is farther from O, isn't it? So it has to win as far as the direction is concerned. That's what a couple does for you. So that's the only time you have to worry about how far is it from O or A. Now if we were going relative to A, then it would be, well, it would still be counterclockwise, wouldn't it? Now, you can do the math on that. You can do a summation of the forces, or excuse me, of the moments relative to O, and it's what? Minus, oops, excuse me, got a little ahead of myself, minus 100 pounds. You know what? I really don't want to have to compete with a clicker. Okay? Times 2 feet plus, right, counterclockwise, 100 pounds, 6 feet. You do the math on that, and guess what? You get 400 pounds-feet. CCW. Summation of the moments at A. You've got this 100 pounds, that's going negative, isn't it? Right? Let's see. Clockwise negative. It's 3 feet. Oops, sorry, I forgot my pounds. Plus 100 pounds times 7 feet. So you got 700 minus 300 is 400, isn't it? Thank goodness they used easy numbers. The positive beats the negative, right? Which means that it's CCW. So these were just to prove that what we did here with the couple actually works. If you see two forces that are going the opposite direction on that same member, you just need to know the force of one and the distance between the two, and boom, you've got that.
Those forces have to be the same amount, though, right?
Yes. Yes. Yeah, the forces have to be the same amount, and you have to know the distance between them, and they have to be the same amount, opposite directions. And think of it as you're turning a steering wheel. If I'm turning that steering wheel and I'm using the same amount on both hands, it's a couple. Man, that's like heaven, because you only have to put one force times the distance, you're done.
Can other forces then be in between them, or what am I?
Yeah, there will be. I think there's a problem. I think example 312 is that. If you look at, let's see. Yeah, if you look at that, notice at point C, you've got that force F2 going down 30. Well, both of them are actual couples. You got a force of 30, and then you've got all the way over to the right, you've got a force of 30 going up, and you got one going down, right? And then you've got a distance of 10 feet, so it's 30 times 10. Then the force F1, you've got a force of 40, one going up, one going down, and you've got a distance of 20. So you're just going to add those two couples up. You wouldn't even have to have the 8 feet and the 5 feet from both directions. The only time, if you would have to have those, if you had to find out what the reaction was at A and B, you have to have the total distance between them to be able to calculate that. But like I said, that's next chapter. Okay. So, some problems to do, eh? Is that what you're looking for? Because we're about done with class for today. Unless you want to keep going. Any reaction on that? Come on. Give me some reaction. Hey, Smith, you're crazy. Oh, I did it on both, the X and the Y, 53.1. But 53.1 is one that we use constantly instead of 51.3, I think, and that's probably what got me. I can show you that. It's probably in that other book, those other problems. It seemed to me like 53.1 was one we use all the time instead of 51.3. Maybe it's the opposite, I don't know. Regardless, let's see. If we did some problems for Wednesday, we might want to do problems like what? Let's see. It looks like now, 324 says compute, otherwise known as calculate, the moment about point A for the linkage shown. That might be a good one. Just for fun, try. Actually, it would be 323, I think, is the problem that it relates to that problem on 322, to the actual picture. So 322 actually goes into 323 there. then
What's Varignon's theorem?
it's splitting that out so that that force F, that force 550 pounds, you've got an X component and a Y component. That's the only difference there. Let's see. 326. Let's do 326. I don't know that you need to do all of those necessarily. Ooh, there's one. Let's do 329 now. I didn't talk about cantilevers, so I want you to try that one though. Okay, it's just a little twist on it. Nothing real tough. Let's see. Yeah, let's. Oh, there's a. Let's do 333. That deals with evenly distributed loads. 334. 336 is a lot like the example problem we had. So let's don't do that one. Let's do 337. Oh, we need to get a couple in there, don't we? Let's do 338. That'll get you into the couples. Then, so we'll make sure you're good with those for Wednesday, and then I've got a little bit more stuff to cover on Wednesday, and then we'll be ready for a test on Friday. Okay? We've got that one section, resultants of non-concurrent force systems. And essentially what you're going to have to do is take whatever force is on an angle and break it up into an X component and a Y component, and then do your moment. Well, the X component will go away because it's going to be going through the point. Okay? But we'll cover that on Wednesday.
Test is Friday.
Test should be Friday. Yeah, in fact, I'm going to write that in there. And I like to call them quizzes. Doesn't sound near as disturbing, does it?
Who is the test?
Do what?
Who is the test to partner?
I still couldn't hear
10
him.
to 20 minutes.
10 to 20 minutes? Yeah, right. You know what? If you've done your homework, it won't take near as long as if you haven't done your homework. So,
Quiz is, test is.
in my book, a quiz could last for hours. Okay? But I'm going to write down quiz. You can call it a test. I like to call it a quiz because it's not near as threatening.
I'm going to call it a test so I take it seriously.
The test, yeah, test. You take all of them seriously in my class, okay? But I told you before, I like to think of it as a way for you to show me all that you've learned. So it's a chance for you to show off.
Are you going to email out those problems that you just said? Or?
I'll put it in an announcement. Yeah, that's what I did the other day, right? Yeah, I'll put an announcement out there, and then after I get these this video compiled, I'll shoot it back out there, and I'll try to spell big announcement right on this next one. I was reading that back to my wife. Said, "Yeah, I made it sound like I was Donald Trump, you know, big, really big. I mean, special." And I misspelled big. Duh. Hey, we'll see you Wednesday.